Alright, what's cracking? Okay, today we're talking about parabolas. And last chapter we touched on parabolas and we talked about the parabolas that open up and down. But today we're going to add a new component to it also. So the graphing form of parabolas is vertex form, which is y equals x minus h squared plus k. Now when it's y equals, it's always going to open up or down. Alright, now we know when our a value is positive, it opens up, and when our a value is negative, it opens down. Alright, but now I'm going to throw another one at you. It's going to be x equals a times the quantity y minus k plus h. Now, look at this. H is attached to x here. K is more attached to y. Here, k is attached to y. H is with x. Alright, so this indicates that my parabola is going to open left or right. Left or right. So when a is negative, it's going to open to the left, and when a is positive, it's going to open to the right. Oh, I forgot my little plus sign. Alright, so now you have to, we're going to handle them the same way, we're going to graph the same pieces. But you have to recognize this and determine, hey, which way is my graph opening, and then apply it appropriately. Alright, so now that we're comfortable with graphing form and all the pieces, let's jump right in. So example 1. I'm going to have x equals negative 2y squared plus 12y minus 10. Now, we got to put it in graphing form, so we need to complete the square. So I'm going to replace my x with my 0, and I'm going to go negative 2y squared plus 12y and move my 10 over. Positive 10. All right, now you need to complete the square. So take out a negative 2, y squared minus 6y. Half of 6 is 3 squared is 9. So I'm adding 9, and I'm subtracting 18, because 9 times negative 2. So that gives me negative 2 y minus 3 squared equals negative 8. Now, I'm going to move my 8 back. So negative 2 y minus 3 squared plus 8. And we know it was x equals to begin with. So drop the x, put a 0, work your magic, and then get to vertex form. Now, vertex form. What does that mean? Well, I know what my vertex means. Now be careful. My vertex is still opposite inside, comma outside. The only difference is h and k are now in different spots, because our y and our k are together. So it's outside is with your x, opposite inside is your y. So it's positive 3. Now, this is a negative a value and x equals, so we know it's going to open left. It's going to open to the left. And then our shape is still the same as before. Okay, remember if the absolute value of a is greater than 1, we're narrow. If it's equal to 1, we're normal, and if it's between 1 and 0, we're wide. Right, so just like last chapter. In this case, 2, remember we're not looking at an absolute value, so 2 would make this graph narrow. Alright, now, to find my x and y intercepts, I'm actually going to do it differently. You can use the calculator, but you'd have to solve for y, and it gets a little tricky. So we're going to do it algebraically for each one. Now, my x-intercept, let's go up here. So my x-intercept, remember your x-intercept is when y is 0. Alright, so if you look here at our original equation, when y is 0, this term would be 0, this term would be 0. So 0 plus 0 minus 10. So x would be left with negative 10. All right, so my x-intercept would be negative 10 comma 0. Now my y-intercept isn't as easy. That worked out nicely. Now my y-intercept, we need to know when x is 0. So what I like to do is I like to take my solved form. All right, this is already, the square is already completed, and now all we have to do is solve when x is 0. So I have negative 2 times the quantity y minus 3 squared plus 8 is equal to 0. So subtract 8. All right, so we're solving just like we did on the last test. Divide by negative 2. Y minus 3 squared equals 4. Square root both sides. So y minus 3 equals plus or minus the square root of 4, which is 2. So y equals 3 plus or minus 2. 3 plus 2 gives me 5. 3 minus 2 gives me 1. So my y-intercepts would be 0, comma 5 and 0, comma 1. All right, so now that I have all this information, let's graph it. Now we need quite a bit of tick marks here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so my vertex, we said, is 8, 3. So there's my vertex. My y-intercepts are 1 and 5. So 1, 2, 3, 4, 5. And my x-intercept was negative 10. So this is what my parabola looks like. It's a beautiful thing. All right, so that's the graph of your parabola, but we're not done yet. Now, I want you to add this at the beginning here. All right, and our F is my focal radius. So just as we've had foci for everything else, we have a focal radius for parabolas also. And how you find it is it's 4F equals 1 over your A value. 4F equals 1 over A. So let's see how that applies to our problem now. All right, so let's talk about our focus. So we have 4F equals 1 over A, and F is what we want to solve for. And in this case, A is 2. We're not going to put negative 2. The negative tells us which way it opens, and now we're just focused on our A value. All right, so 4F equals 1 over 2. So then we would divide both sides by 4. Ooh, put FF. So now we're going to divide by 4. 1/2 divided by 4 gives me a focal radius of 1/8. Now, with that information, we're going to find two things. Okay, one is my foci, and it's a coordinate similar to what we did with ellipses and hyperbolas. Then my second piece is called the directrix. Directrix. All right, so with my vertex, we have an axis of symmetry, all right, which we should be familiar with from last time. Okay, and our axis of symmetry we talked about with parabolas would be if I were to draw a line through the vertex. Okay, if I were to split this graph in half, a symmetrical line of some axis of symmetry. All right, now your focus and your directrix are going to lie on your axis of symmetry. Now, I'm going to rewrite the vertex 8, 3. Okay, now your axis of symmetry is a horizontal line that goes through your vertex. So my axis of symmetry is y equals 3. That's the equation. Now, we're going to go 1/8 in either direction from the vertex. Remember, your foci are always inside of your graph. So if we were to go 1/8 to the left, we're changing my x coordinate. So what's 1/8 down from 8 would be 7 and 7/8. And my x value would stay the same. Now, it's really, really, really close there. Is my F1, is my focus. Now again, just leave it as exact. We can do an 8 down from 8. All right, 7 and 7/8. Then for my directrix, we're going to go 1/8 in the other direction. And the directrix is actually a line. All right, so it's going to want the equation of that line. Well, you went 1/8 to the right of 8. And it's a vertical line, so it's an x equals line. And 1/8 to the right is 8 1/8. All right, so the focal radius is you go in each direction from the vertex. Inside of your graph is your foci. Outside of your graph is your directrix. Now, that's everything you need to know for parabolas. Doesn't look like we have time for another one. When we get to class tomorrow, we'll do 2 more together. Again, we have a lot of different types of graphs now. All right, now try to get this all in one view for you. We have a lot of different types of graphs now, so be comfortable with each, understand what each needs. And each day, that's a lot of eaches, we'll continue to harp on this and really organize it and make these connections over our review days here. So, have a good night. See you tomorrow.